All right, we're gonna step it up by like 10 smidgens. We're gonna take a look at the following. Yeah? Yeah. Yeah, why not? Y'all just chilling on the couch today. Why not make this a little difficult for us? By difficult, I mean that this one is going to require some exponential knowledge that we've certainly seen before, and at some point in your mathematical career, you've had to deal with this. It's just, you don't always have to deal with it in calculus, so it sort of goes in the back of your mind, you just have to pull it out. And that's what we'll do today, at least for this video. Okay, so if I take a look around in the back of my book for a table, this looks an awful lot like it probably should be, I don't know, table 2, number 8. I feel like that one is most beneficial for us. Let's see, something like the integral of e to the ax times sine of bx dx should equal 1 over a squared plus b squared times e to the ax times a sine of bx minus b cosine of bx. Oops, forgot parentheses. And plus c, yeah, we know. We'll get there, don't worry. Okie dokie. Seems like a lot, I know, I get that. And we talked a lot about developing what these variables are and all that kind of good stuff. But we're just not quite there yet because I need this in here to not be a function. I mean, I don't want 5t plus 7 because this currently is just a coefficient times x. And so we need to fix this a little bit in order to do that. And what we're going to do is use some use substitution methods first. And gosh, I wrote that right in the way, didn't I? What a pain. Okay, that's fine. That's cool. Let's go ahead and let w equal that inside function, 5t plus 7. So then what we can now do, find dw, and that should certainly equal 5 dt. Therefore, dw divided by 5 is equal to dt. And what we can do is start substituting some things in and see where that gets us. Particularly, now we should have the integral of e to the t times sine of w, and then substitute in dw fifths. Now, we're going to run into another issue that, same one we had a couple of problems before, that we have a t and a w in there, and we're taking dw, so we need to have just w's. How do we get rid of that t? Well, we don't actually get rid of it. Notice up here we have what t is equal to in terms of w, or at least we have w in terms of t. What if we were to go ahead and solve this for t? Namely, what if we were to take w is equal to 5t plus 7, subtract 7 and then divide by 5 to give us w minus 7 fifths. Now we take that and plug that in for t to give us my integral of e to the w minus 7 fifths times sine of w dw over 5. Now this problem here is going to take a little bit of loving to get it to look still what we want it to look like. And that is where exponential rules come in. So here's what I want to do. Over here, I'm going to deal with this e to the w minus 7 fifths. And we're going to simplify this down as much as we possibly can. What I mean by that is I want to split it up so that I just have e to the one variable. Well, I can certainly write this as e to the w fifths minus 7/5, right? I can take that fraction, I can separate it into two parts. There's absolutely nothing mathematically incorrect with that. Then, I could write that as e to the w fifths plus a negative 7/5. And then let's also recall, if you go way, way back into algebra, you would have remembered that if I have x to the m times x to the n, that should result into the sum of my exponents, which means that if I have e to some power times e to some power, I can write e to the sum of those exponents. Or reverse, I can do x to some sum and separate that into the product of two bases. So if I have e to the sum of two exponents, I can separate this out into the product e to the negative 7/5 times e to the w fifths. You probably wonder, why on earth are we doing any of that stuff? Well, because this is a constant. Remember that one of the biggest keys with integrals is you can always pull out coefficients or constants that aren't being added or subtracted. You can pull those out, much like if I were to, again, this is our recall board section. If I had something like the integral of 5 times t, that is the exact same thing as 5 times the integral of t. There's nothing wrong with pulling out that constant. So if I have something like up here, the integral of e to the negative 7/5 divided by 5 times e to the w fifths times sine of w dw. Again, I took that 1/5 with the dw, or the divided by 5 with dw, moved it over to my constant, because all of this here is just a number. I have no idea what that number is. I couldn't care less what that number is, but it's a number. It's some coefficient. It's just like 5. I can pull it out. So I can now have the integral, e to the negative 7/5 over 5 times the integral of e to the w fifths sine of w dw. And now I can use the table from here. Because my table, I apologize for that. The table says e to the ax times sine of bx is equal to yada, yada, yada. Well, we have that here. It looks a little bit different. I'll write this a little bit nicer and cleaner. I'm going to write e to the w fifths. I'm going to write that as e to the 1/5 w times sine of w dw. And that tells me that for my problem, a should be 1/5 and b should be 1. Now I'm running out of room here. I don't want to use the other board. I'll use this the best that I can. I know, it's all jumbled around. I apologize. It's because this stupid thing got in the way. I don't even know why I bother writing that. They're in the book. It's because I care about you guys. Most of you guys. Some of you. Well, I care about 1 or 2 of you. Just kidding. Okay. Use this fella. Use a and b. That's 1 divided by 1/5 quantity squared plus 1 squared times e to the ax, which is 1/5 w, times, and I know my whole body is running away, times a times sine of bx, which is just w, minus 1 times cosine of bx, which again is just w. And obviously there are a number of things that you can do in here to deal with all this, meaning I'm not going to reduce this very much. I'm going to put that as, well, Okay. Nope, I don't wanna do it. Now, one thing that I will do now is I'll start substituting in W. W, recall, is 5t plus 7 times sine of 5t plus 7 all over 5 minus, minus cosine of 5t plus 7. I know the handwriting is extremely small, plus c. I will zoom in with the camera here in just a second. How do you zoom? Oh yeah, look at that. Got it. So all that was in that last step was just substituting in W.